Hello everyone. In today's class we will be dealing with complex number. When talking about complex number is in form of what? A plus IB. Where A and B is our what? Real number. And here is our what? Real part. And here is our what? Imaginary part. So and I equals what? Square root of what? Minus 1. So now, before 16th century, there was it was difficult in solving square root of a negative term. Like now, for instance, square root of minus 4, it was impossible to find not until 16th century. The idea of I equals minus 1 came from 16th century. So now, to solve this idea using your sword method, we can split it into two. We can have square root of 4 times what? Minus 1, right? In your sword, you can say root 4 multiplied by what? Root what? Minus 1, right? And root 4 is what? Is 2 multiplied by what? Root what? Minus 1. And note that I said that I equals what? Minus 1. So therefore we have what? 2 of what? I. Therefore, if you want to, it's possible to find a square root of a negative term. So now we'll be looking at how we represent complex number. We have what? The representation of what? Of complex number. So we have the representation of what? Of complex number. The first one, we have what? The rectangular or what? Or Cartesian form. And is represented as what? Let's say you have a complex number z equals what? A plus what? IB. Or we have what? Or we have A comma what? Comma B. That's what we call rectangular or Cartesian form. And the second one we have polar or what? Or circular form. And is, let's say we have what? A complex number z is what is represented as r what? Cos theta plus what? I sin what? Sin theta. This is how we represent complex number in what? In polar form. And the third one we have what? We have the exponential or Euler's form. So we have the exponential or Euler's form, and it's represented as what? Let's say we have complex number z, and it will now be what? R exponential I theta, where our r is what? Is the modulus. Is the what? Modulus. And our theta is the what? Is the amplitude. Amplitude. Okay, so now we'll now be looking at what? Algebra of what? Of complex number. We have the what? Algebra of what? Of what? Complex number. When dealing with algebra of complex number, we have what we call the multiplication, the addition, and subtraction and division of what? Of a complex number. So now, when dealing with complex number, let's firstly look at what? Addition of complex number. Let's say we have two complex numbers z1 to be what? a1 plus ib1, and z2 to be what? a2 plus ib2. And they said we should find the addition. Then now it now be what? z1 plus what? z2. Now we have what? a1 plus what? ib1 plus what? a2 plus ib2. Okay, so now let's expand the bracket. We have a1 plus what? ib1 plus a2 plus and plus what? Is still plus what? ib2. So the addition, if you want to add a complex number, I said that we have two parts in the complex number. We have both the real part and what? Imaginary part. So here you now bring the one that have real parts beside each other, and the one that has imaginary parts beside each other. Now this is a real number. So say a1 plus what? a2 plus the imaginary part, which is what? ib1 plus what? ib what? b2. That's how you add complex number, two complex number together. Okay, so now let's look at an example. Let's say you have what? z1 to what? 2 plus what? 3i, right? And you have z2 to be what? Let's say 4 plus what? 9i. Are you getting it? So if you want to add complex number, you have what? z1 plus z2. You can just use the formula. This is our b, this is our a, this is our b, this is our a, this is our a1 b1, a2 b2. Are you getting it? So you can just use the formula for what? For addition of complex number, which says a1 plus a2 plus ib1 plus ib2. Okay, so we have a1 plus a2. A1 here is what? Is 2, and a2 is what? Is 4, right? Plus we have what? b1 ib1 I, we have b is what? 3i plus what? b2 is what? 9i. So here z1 plus z2 equals what? 2 plus 4 is what? Is 6, plus you can factorize I out. I 3 plus what? Plus 9, right? So 3 plus 9 will give us what? Will give us 12, right? It will give us 12. So now z1 plus z2 equals what? 6 plus what? I what? 3 plus 9 is what? Is 12. So z1 plus z2 equals what? 6 plus what? 12 I, or I 12. You see the same thing. That's how you add up a complex number, two complex number together. So we are now moving to what? To the subtraction of what? Of a complex number. Moving to subtraction of a complex number. Let's move to the subtraction of complex number. You have the word subtraction of what? Of complex number. We are still on algebra of complex number. So the first one is what? Addition of what? Of complex number, and the second one is what? Subtraction of complex number. We'll be looking at, after this subtraction, we'll be looking at multiplication of complex number and what? And division of what? Of complex number. So let's move to subtraction of complex number. Let's say we have z1 to what? A plus what? IB, and z2 to what? A plus what? A1 B1 A2 what? IB2. So after that, we can, the formula now, subtraction of complex number is what? Z1 what? Minus what? Z2. Right? From here, you have Z1 to be what? To be what? A1 plus what? IB1, and what? Minus A2 IB what? IB2. Let's expand the bracket. So here, there's nothing to worry about. Is what? A1 plus what? IB1. And this minus plus, and this minus as affects the one in the bracket. So now minus stands, there is a plus sign here, but it's invisible. So minus times plus what? Is minus what? A1 A2, minus times plus is what? Minus what? IB what? B2. So now when we are dealing with addition of complex number, I say that we bring out the real part to one side and the imaginary part to what? To one side. So now we have what? A1, our A1 and A2 is what? Is our real part. So we now have A1 minus what? A2, right? And bring the imaginary part together, which is what? Plus what? IB1 minus what? IB2. So that's how we solve subtraction of what? Of complex number. Let's look at example. Let's say we have what? Z1 to what? 2 plus 3i, and Z2 to what? 5 plus what? Let's say 1 plus 1 plus what? I. Okay, so now from here, since we've getting the formula for subtraction of what? Complex number, we can apply it in the example. So now we can apply this formula to the example. So now if you have Z1 minus what? Z2, right? So now our A1, A2, this is our A1, and these are what? A2, which is 2 is our A1 and 1 is our what? A2. So now from here, our B1 is what? Is 3, and our B2 is what? Is 1. It's invisible. There is 1 here, but is what? Is invisible. So now we have what? Our A1 is what? Is 2, and our A2 is what? Minus what? Minus 1. That's how you subtract a complex number. And plus times plus, we write plus here, right? So now our IB1 is what? Is 3i, right? Is 3i, and our IB2 is what? Minus, right? Is minus, because we are dealing with what? Subtraction of what? Of complex number. And it should now be what? Minus plus 3i minus what? Minus I, right? So we have Z1 minus Z2 to be what? 2 minus 1 is what? Is 1, plus what? 3i. Let's factorize I outside, and we have what? 3 minus, that is invisible one here, but you can't see it. So 3 minus what? Minus 1. So we now have Z1 minus Z2 to be what? 1 plus what? What? I2, right? So you can rephrase the question. Z1 minus Z2 equals what? 1 plus what? 2i. That's how you subtract a complex number. So next one, we are going to what? Multiplication of what? Of complex number.